Hi, welcome back to Mr. Slover's Math. Today we're going to focus on slope. You're going to be able to describe and calculate the slope. There are four different types of slope. So since we're focusing on linear functions, all of our graphs, when we graph them, are going to be straight lines. Remember, linear means that it's going to be a straight line. So the first example is positive slope. And the common question is, well, how do you know it's positive? It could be negative. Well, you read left to right. So when we look at a graph, we start at the left side and we go to the right side. So I'm starting here and I'm going up. So let's think logically. If I'm going up, imagine there's a person walking. Imagine my cursor is a person and you're walking up the stairs. So I walk all the way to the top of the stairs. Did I go up a positive number? Did I go up flights of stairs or different levels or different floors? Yes. So it's positive. The next one is an example of negative. So once again, we read from left to right. So I'm starting at the left side of the graph. Now I'm going down these stairs. Well, I'm going down. That's going to give me a negative number, a negative slope. This one might be kind of tough to see on the video, but this is a horizontal line. I always like to think of the horizon, which goes left to right. So this is a horizontal line. My slope is 0. The last one is a vertical line. So vertical means we're going straight up and down. Your slope is undefined. Here are just some practice examples of identifying whether it's positive, negative, 0, or undefined. The variable m represents the slope. Remember, that's just a number. There's usually not a number. Usually there's not a variable with it. It's always found in front of the variable x in a linear function. If there is not a number in front of the x, the slope is considered to be 1 or negative 1. And your generalized equation is y equals mx plus b. So I do say the slope is always in front of the x, and we're actually going to see some special equations where what if we don't have an x in our equation? And we're going to talk about that and what it means. Here are different ways that we can visualize what slope is. It's the change in the vertical y value over the change in the horizontal x value. You may have heard of it as rise over run. And then the other option would be to figure out the slope using some ordered pairs, y2 minus y1 over x2 minus x1. So example 2 has quite a few in here, but it's showing 3 different types. So we're going to talk about the 3 different types that we could do. The first one is if it's already graphed, let's go the easy route and just count the rise over to the run. You need to pick 2 points anywhere on that line. Now, I like to encourage you to pick whole points. And so what I mean by whole point is the line should go through the corner of one of these boxes. That way we know it's a whole number. So if I have kind of where the top of my cursor is, if I pick a point there, right there, I don't know what that number really is. I could guess, but it wouldn't be accurate from person to person. So when you pick points, you want a whole number. So this point here is a whole number. This point here is a whole number, meaning if I were to graph it, right, it's maybe integer would be the better word than whole number because we can have negatives. So you want it to be an integer. I could graph this at 2, and then it looks like I go up 4. So 2, 4. Okay, so that's what I mean by integer. So I pick my 2 points and I just count how many up and over or down and over. In this case, I'm going up and then to the right. So because I'm going up, that's positive, and to the right is also positive. So up 1, right 2. My slope is a half. Leave it as a fraction. Letter B. It's not graphed. I could graph it, but I don't have a graph. So I'm going to show you what to do if you don't have a graph. You're going to label it x1, y1, x2, y2. You're thinking, well, Mr. Slover, why would I label it like that? Your ordered pair, any ordered pair is always listed as x comma y. Well, since I have two ordered pairs, I need to distinguish between which ordered pair is coming from. So the first ordered pair has the ones, x1, y1. The second ordered pair has the twos, x2, y2. I'm going to take those numbers and I'm going to plug it into this equation, this formula. y2 minus y1 over x2 minus x1. So y2 identified as 1 minus, that's in my equation, y1, which is 3, over x2, which is negative 2. My equation, my formula tells me I have to have a minus, and then over x1. So I get 1 minus 3, which is negative 2 in the numerator, negative 2 minus 2, which is in the denominator. And right here I have a little sign, highlight reminder that I want you to reduce if possible. So this one does reduce, and it's as simple as you just plugging it into your calculator. Negative 2 fraction negative 4. That's totally fine. So it reduces to 1 over 2. Letter C. You may have seen a table like this in science class. Or you may not have, I don't know, but that's where you could have seen a table. So this is, instead of me graphing it, or instead of me telling you ordered pairs, I'm giving you a set of data. And based off that, can we figure out the rate of change? And we can. So if I'm going in my x values from 0 to 2, 2 to 4, 4 to 6, I'm adding 2 each time. If I look at my y values, I'm going negative 4 to negative 3, then to negative 2 to negative 1. So I'm adding 1 each time. Your slope is the change in y over the change in x. So my y values are changing by 1. My x values are changing by 2. So 1 over 2 is my slope. Let's look at letter E. So letter E, when I plug it into this formula, the y2 minus y1 over x2 minus x1, I end up getting 20 over 0. When that happens, or when it happens again, because it will, make sure you reduce it. And don't just leave it as 20 over 0. What does that mean? Well, it means my slope is undefined. It means that I have a vertical line. That's what a slope of undefined is. I have a vertical line. So please make sure you reduce anything that can be reduced. And here's some more examples that you can work through on your own. Example 3 is just asking us to state the slope for each of the following. So we're using y equals mx plus b, which is right here. So m is your slope, b is your y-intercept. Remember, that's where it crosses the y-axis, but we only need to worry about the slope on these. So the slope is a number that is attached, if you will, to the x. So y equals 3x. My slope is 3. Y equals negative x plus 1. Well, that negative x really has a coefficient of negative 1. So my slope is negative 1. C and D are my two special cases. This one just says y equals 5. There is no x value. So how do I know what the slope is if there's no x value? Because my slope is told me it's by the x value. Well, this is a special type of line. Y equals 5 is a horizontal line going through 5. So a horizontal, remember, is going left to right. So a horizontal line has a slope of 0. If I look at letter D, it just says x equals negative 8. There's nothing else with it. Well, once again, this is a special type of line. If I have x equals negative 8, that doesn't mean my slope is negative 8. That's not what it's saying. It's saying I have a vertical line at negative 8. So your vertical line is going straight up and down. That means my slope is undefined. There's some more examples that you can work through in example 3. Example 4 is asking you to use the slope and y-intercept to write an equation of the line. So here's my slope, which is my m. Here's my y-intercept, which is the b. And I'm just going to replace those letters, those variables. Slope is 8, y-intercept is 4. So y equals 8x plus 4. In letter C, I already tell you the m and I tell you the b, so it's a little bit easier. So y equals negative x, or if you have negative 1x, remember it's the same thing, and then plus 0. Now, if you don't put the plus 0, that's okay. Because if you think about it, if I have $10 and I add $0, I still have $10. That plus 0 isn't changing my equation in this case. Letter E and F are both the special cases. Slope is 0, so right away, if you have a slope of 0, you should be thinking horizontal line. So I have a horizontal line at negative 4. Y equals negative 4. My b value, my y-intercept, is negative 4. You can also write it as y equals 0x minus 4. However, it's more common to write your equation this way. And then the last one, I have a slope that's undefined, so that means it is a vertical line. And here's my x value of 5. So I have a vertical line of x equals